We're very lucky to have Samantha Webster, who's going to talk to us about gonorrhea in Australia. Samantha works as a genomic scientist at Pearl, the Public and Environmental Health Reference Laboratory. She works on developing and implementing innovative strategies for gonococcal surveillance, which, quite frankly, is a noble work, and investigates antimicrobial resistance in STIs. So she's going to talk to us about the changing landscape of gonorrhea in Australia today. Thank you.
As Andrew said, my name's Sam. David Wiley told me to come and do this talk. And so I'm really happy to be here today. But as mentioned, I'm under either Queensland Health or Pathology Queensland, whichever part of the merger you've been aware of, talking about gonorrhea today. So the clap, or gonorrhea, is back in a big way. As Emma mentioned, it's an STI, but it's untreated can lead to some really nasty long-term sequelae, pelvic inflammatory disorder, birth complications, adverse birth effects, or even disseminated gonococcal infection, which is kind of the step before sepsis, where gono gets into your joints. Really uncomfortable, relatively common in nursing homes, unfortunately. It's been rising considerably over the last decade or two. And in 2020, the World Health Organization estimated about 82.4 million new cases in 15 to 49-year-olds that year, which I would suggest is probably an understatement of the actual infection load, because I think that people over 50 do have sex and do get STIs. But we'll get into that in a minute. It is a pathogen of concern primarily because of its propensity for AMR development. It made the 2012 CDC watch list and has been on there ever since. And in 2017 was assigned a World Health Organization priority pathogen. Got a bit of star power. And the increasing AMR burden globally kind of confirms this. So the WHO basically did this enhanced gonococcal antimicrobial surveillance program over 2019 to 2022, got a bunch of countries, anyone they could, to buy in and do some surveillance of this. And then that team went and wrote a paper about it. And the key things that fell out of this data was that in 39% of countries, and reminder that these numbers can be a little bit flexible in some places because not every country has the same surveillance program or protocol. But in 39% of countries that reported, there were isolates with cases of decreased susceptibility to ceftriaxone, which is a problem because that is a first-line treatment. In 50% of reporting countries, decreased susceptibility to sulfixime, which is similar to ceftriaxone in that it's a third-generation cephalosporin. And in 88% of reporting countries, resistance to azithromycin, which is concerning because that is either a part of a combinatorial treatment in most places, or it's a second-line antibiotic. And 99% of reporting countries reported resistance to Cipro. Now, we did see recent changes to the TGA equivalent in the UK, kind of pulling Cipro treatment on the basis of bad side effects to patients, but I would hazard a guess to say that this report might have something to do with that, just because there's such a high burden of resistance. And I just wanted to highlight that this is data from the reference lab, kind of showcasing across time our percentage of isolates, kind of showcasing those phenotypic resistant traits. And so it's very similar to those stats. So in red here, you can see the Cipro has just completely exploded. The tetracycline in blue, also pretty bad. The penicillin has kind of seemingly calmed down in recent years. I have some thoughts on that, but unfortunately, I wouldn't be able to get into that today until much later if someone asked me a gnarly question. But skipping ahead, I wanted to give you a little bit of a snapshot of the country. This is pulled directly from the NDSS dashboard, which is our big, the CDC has taken, the Australian CDC interim has taken it over. And Queensland in purple here, with 7,565 cases of gono reported and detected in 2025. So this is just notification rates since 1991. You can see that huge boom. Here's our surveillance totals. Sometimes our state totals don't match up with our national totals, but in this case they did. And I had a look, and it does turn out that according to our national metrics, this is a graph based on age group and sex, and people over 50 in Australia do have sex. They make up about 7% of cases, and I think about 39,000 infections. So big group to discount. Ask any STI researcher about nursing homes. It's very fun. Um, and I think this is a Kirby image. I love images like this because in Queensland we do have this darker area at the top in central Queensland, and then not that you can see it super well, but down in southeast Queensland as well. The darker areas indicate more notifications. So heaps of our notifications come from areas, unfortunately, that are relatively underserved by either processes or by sexual health clinics. There's just simply less per person in that area. So this is something of interest, and I'll get into that in a second. But I kind of look at graphs like this and look at some of the health services research that comes out. And I went and had a look at the 2024 data a while back now. Need to update them, but didn't get time before this talk. And I looked at the percentage percentage of our isolates produced per HHS. And lo and behold, all of my numbers are up on the screen, but the biggest takeaway is that this little corner of southeast Queensland produces 71% of our isolates. So that's been able to be detected, cultured, and is present isolated in the lab. We only get 20, despite that high number of infections that you're able to see in the last picture, only 20% of our isolates come from far north Queensland. One of the things that I'd like to just caveat here is that a lot of things die in transport, unfortunately, for gono, or the labs might not have the access to the relevant incubators that they need to grow this, or patients might even not be comfortable being swabbed and would be preferring a NAT. So that happens, but then also we only get 2.4% of our isolates from central Queensland. And I would say that, I happen to know that we've got a nice, well-staffed and well-resourced lab in Cairns and a nice well-resourced lab next door. But in central Queensland, which is, central west and central Queensland on this graph, on this image, the isolate has to make it from the point of care straight, just in a truck kind of straight here. So it has to be couriered all the way down. And it doesn't always survive. Sometimes it's not taken. Clinics are hard to get to, etc. And this was of interest to me because we do clinical antimicrobial resistance alerts. So Triple N or whoever is interested in our critical alerts. And so that means that in some cases where those phenotypes of resistance are obvious in the lab, they've been tested for antimicrobial susceptibility, they then come all the way through and they get whole genome sequenced if they've met all of those thresholds, so they're looking really resistant. And so of those 20% of cases that we get from far north Queensland, 6% of these come all the way through to WGS, meaning that they are resistant, critically resistant. In southeast Queensland, where we get 70% of cases, got a bit of a higher rate making it through to whole genome sequencing. So not unexpected, really. Metro areas tend to be more resistance factors and different types of communities. But of that 2.4% that comes through from central Queensland, 25% of those samples make it through to whole genome sequencing, indicating that there might be a couple of different things happening in that data set. Maybe only people with these quite persistent infections are getting screened, which is an access problem. Alternatively, it might be that we do have a disproportionate resistance problem. Maybe people are overusing antibiotics because they can't get to the clinic or what have you. But I think we really need to dig in more to that problem in particular if we're trying to make sure that there's equity across the board in treating these infections from here to Cairns to Cape York to Thursday Island. So I recently gave a Pride of Science talk and I love my cartoons. So this is our gono in the top corner, and I just want to highlight what has happened and how we've kind of ended up here. So our gono over time, we started with penicillin in the 80s, then ciprofloxacin, 91, right? So just to recap, penicillin targets cross-linkage, peptidoglycan, cell wall, weakens. That has slowly become less effective. And Cipro is a fluoroquinolone. And as Emma mentioned, PAR-C and DIARA mutations in Neisseria also have developed over time, meaning that in 2001, they switched to a different treatment. Ceftriaxone in use from 99 to now. Similar mechanism of action to penicillin though, because it also targets cell wall synthesis. And azithromycin, a macrolide, second line of treatment, still currently in use. Combinatorial, depends on the jurisdiction. But I just wanted to point out that over time, we can see these tracked in data as well. Shout out to Sarah Bell, who's amazing, who made this graph. I think it's really, really great. So what this graph is showing you is essentially from the 80s to 2025, using Australian data, you see that as an antibiotic is introduced, the resistance rates in gono go way up, and then we switch treatments, and you see the pattern repeat over and over and over again. And even with this azithromycin, you can see this little bump only starts to go down as we transition into like more ceftriaxone therapy. And the important thing to note is that 5% line, which is the recommended threshold to switch drugs. But we're running out of drugs. And if you look at our graph, I don't actually have my numbers on screen, but tetracycline, as of 2025, resistance was about 35% of our isolates. I think that Cipro is like 70%, give or take, just under 65. And that azithromycin is at 7%, so indicating we would be due for a switch. But when there's no drugs really on the market that are alternatives, what do we do next? So I happen to know of a drug called gepotidacin, which is in the pipeline at the moment. However, I'd like to point out that that's got a really similar mechanism of action to fluoroquinolones, also targets gyrate, I believe. And given that we know that gono is so mutable, we should really be implementing big surveillance and any other mechanism that we can think of to try and get on top of infections, but also to keep track of what's going on, because otherwise we might well end up in the same situation in 5 to 7 years' time. So back to my cartoons. I would say that with multi-drug and extensively drug-resistant gono, we're now looking at a fight that looks a bit more like this. And you can see my jacked up gono indicates our XDR cases. So in 2018, we saw our first XDR case in Australia. I work with Amy Jennison very closely, who Amy was kind of like spearheading this, I believe, in Queensland, because this case came up in Queensland, and just really wanted to get to the bottom of what was happening with this particular case, because that is a change from a single oral treatment or an intramuscular injection and a week off sex to you're now in hospital for 3 days. This is quite an extensive therapeutic approach. And so looking at this, they kind of mapped it, and they genetically proved that it was very, very similar to an earlier case from the UK in the same year. And then they mapped it back, and it looked very similar to a 2014 UK case. Now, all of these cases were travel associated coming out of Southeast Asia. This is not uncommon or unexpected. The Asia Pacific region scores really high in antimicrobial resistance and STIs on the WHO metrics, partially because they have different antimicrobial resistance stewardship principles at play and different prescription mechanisms, etc. But I think that we need to be really looking to work with our partners instead of maybe just throwing them under the bus all the time. That's a personal opinion. So to follow up from that case, which was really concerning, and one of the key molecular mechanisms being the PAN-A60 allele, which is a mosaic gene that kind of likes to rearrange itself to become more resistant and confers high-level ceftriaxone resistance. I believe Ella Trembisky, who works closely with David Wiley's team and Amy's lab, kind of got together. They did a huge amount of surveillance and screening of a huge amount of isolates across several states in Australia, and they found, I think, 1 or 2 cases from memory, but no local transmission, no cryptic transmission, which is really promising because we're quite concerned about ceftriaxone resistance emerging. And then this paper hit, I believe, in October of 2024, and Monica Lara's lab in New South Wales, so Public Health New South Wales, they reported in this paper, mind you, this is not necessarily like an original research article, this is a correspondence article. So relatively, I believe this should have been a paper of its own, but public health officials were obviously concerned enough to put this in correspondence just to get it out there. And they reported 8 cases of XDR. And they went even further. David was on this team as well. And they kind of looked as deeply as possible to try and say, well, what has happened? How did these strains of XDR emerge, and why have we detected since 2018? I think there were 3 XDR cases at 2018, and since then, 16 more have been reported, 8 of them being in New South Wales, 2 of which were reported during the time that they were writing this article. And so they found, I really enjoy this image, although I find it relatively difficult to follow this tree. But essentially, what they found was there were 3 main events. Firstly, there was the PEN-A allele. Sorry, firstly, there was the macrolide resistance fixation, so the 23S mutation. Secondly, there was the PEN-A60, which confers high-level ceftriaxone resistance. And then there was a third, the switch from the 12039 MLST to the 16406. Now, almost all of the XDR cases, I believe, are the MLST 16406. There's one singular change in a housekeeping gene, so it's not necessarily highly important for resistance outside of us being able to screen for it and say, okay, MLST 16406 is something to watch out for. All of this to say, I think we can see that this is highly escalated, and the big point I wanted to make here is that set of mutations occurred by 2016. It's proposed in this article, which means there's an 8-year lag between when the mutation happened and when this article was published. So we need to be a little bit more on top of it. And this is from a bioinformatician that we used to work with, who is just brilliant, makes much better figures than I can. But the point is to show you that there's a big shift in the MLST numbers per year, but the thing that we really want to keep an eye on is the NG stars and the other antimicrobial resistance prevalence. So if you see this big yellow one on the left here, MLST 1580, huge in 2023, there's more diverse MLSTs available the following year. So things change over time, but the antimicrobial resistance typing is something that I'm quite passionate about. Again, just to show you that the distribution of MLST profiles tend to fluctuate per year, they can keep an eye on kind of what's currently going on. But I would argue that the typing of antimicrobial resistance genes is much more informative. And again, so this graph on the right here is the one that I wanted to really have a think about, because you see that there's all these novel types popping up in the NG stars. So if 2024 is in orange, 2025 is in blue, you can see that there's these changes per year. But what we really need is a really comprehensive database that says, okay, this is the type that we found, and this is the clinical relevance of that type. As Emma was saying earlier, I think it's really important that we link those two things, especially when we're in an environment where we're running out of treatments and we need to be on the ground now, making sure that that treatment choice is directed by real data. Similar, just keeping an eye on the NG star types as well. So these Sankey charts are really great because they show you the MLST on the left and the NG star on the right. Again, that 1580 to 1038 on the left in 1 year is much reduced in the following year. So we really need to be on top of these trends as quickly as we can. So what are we doing about this? Well, we already do whole genome sequence all of the correlates, so all of those critically resistant isolates. However, I would argue that we need an amplicon typing method, which I've been working on for 2.5 years now. It's finally in a validation phase, which is great, but this is so that all of those isolates that don't quite meet the threshold for that resistance process of whole genome sequencing, we could then genotype all of those to know what's coming next, so that we're not in the same situation of reporting 8 years after the fact that we've now found heaps of new cases or this particularly problematic mechanism. So genotyping of isolates which don't quite meet that threshold is super important, and being able to get typing information from the clinical samples on request would be really, really important for clinicians. I've recently worked on, thank you so much, on comparing the amplicon method to hybridization baits, and found that the baits unfortunately did win out, despite being a much more expensive method. Perhaps that is for a reason in this one case. What we're looking forward to doing is doing a wider AMR snapshot over the last couple of years and working through any backlog that we can to see what's been going on with our isolates, and to be able to offer some kind of A, what's happening, and B, almost like a gentle predictive suggestion of what might emerge next, or what has already been quietly emerging. And then dashboarding all of that AMR information is currently in development in-house. My hope is that during my career, we're able to get that to a point where we can just send links out to either requesting clinicians or researchers, because I think that interactive format is so helpful. And then also working through a mosaic allele hybrid sequencing method, because the PEN-A60 allele is actually quite difficult to sequence because it does like to move around. So any Illumina sequencing can be quite challenging to then reconstruct because the gene itself moves in a modular fashion, which is a scientific problem that is quite frustrating. But I just want to give you a bit of a sneak peek of this idea of a gonorrhea dashboard. It is in development. It already has a load of data in it, but obviously it's moving through Queensland Health's internal approval system. And so the aim would be to have all of that clinically relevant data, but also a little bit of a map for our clinicians or any other partners that we're hoping to use this and work out what's going on in particular areas. Are we seeing everything pop up in a particular time frame or in a particular jurisdiction? Are we seeing that there are particular transmission dynamics at play? And then also these phylogenies, so that anyone who is interested in the evolutionary kind of process or model would then be able to take that information and move further, similar to that paper, but maybe in a more timely fashion. And yeah, this was one of my cartoons that I promoted for my Pint of Science talk. I think it's just important that we move towards a personalized medicine model where we're aware of that, what's going on in all of the genomes, and that surveillance-directed choices are able to be made by clinicians so that no one's left in the dark or left behind. So I just wanted to thank you for having me today, but also thank you to everyone who has worked on any part of this. There are so many people involved behind the scenes, and thanks to David for putting me up for this talk.